Welcome to the Control Engineering webcast, Leveraging Artificial Intelligence to Maximize Robot Efficiency, sponsored by Universal Robots. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type the questions for our speaker in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with a link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. I'm happy to introduce today's distinguished speaker, Tim Degrasse. Tim is an automation specialist for Universal Robots covering Northern California. He spent the first part of his career working on the manufacturing floor with L3 Technologies before transitioning to high-tech sales. He moved into the automation market in Silicon Valley with Keyence Corporation and then Universal Robots, where he has worked the past 4 years. Tim holds a bachelor's degree in hardware engineering from University of California, Santa Cruz. With a passion for helping companies adopt innovative technology, Tim has helped deploy dozens of collaborative robots using AI, helping customers stay ahead of the curve in the global manufacturing marketplace. Tim, please go ahead with your presentation.
Yeah, hi Mark, thanks for the introduction. Welcome everybody to our presentation today about artificial intelligence and machine learning with collaborative robots. So first off, we're going to kind of do a high-level overview of what is artificial intelligence, how does it relate to me, how does it relate to you, how does it relate to manufacturing. When we are talking about AI, the words AI and machine learning and deep learning all kind of get thrown around together. And so today we'll explore how are they the same, how are they different, and then also kind of look how is that being used in manufacturing with robots specifically. So we're going to talk a little bit about how it's used outside of robots, but then also with robots and our robots also. We're going to explore, will artificial intelligence work in your manufacturing plant? Every plant is different, so it's going to be hard to exactly pinpoint it, but I'll give some kind of high-level overviews and scenarios, and you can be the judge if that relates with you. Also, as with any new tech, artificial intelligence is going to sound really expensive, so we want to talk about, what are these costs? What are the right ways to invest in AI? And what is the right way to look at this? And a little sneak peek, we always want to look at this from the return on investment perspective. So anytime you invest in anything, especially automation or artificial intelligence, you want to figure out how quickly is that investment going to come back to you and start generating revenue for you and your company. And who can I talk to, right? So who are the right people to reach out to? Who are the trusted advisors that you can connect with to help put you on the path to success? And then, the big question that I think a lot of people have, especially you watch movies, you read the news, you see in the media, will AI steal my job? The short answer to that is no. We're seeing that AI and automation are creating jobs in industries much faster than they're replacing them. It all kind of also comes back to training and learning. And so congrats to all of you for tuning in today to learn a little bit more about artificial intelligence and hopefully add more tools to your tool belt and to your toolkit as you progress through your career. So first thing we're going to do is we're going to watch a video here about AI versus machine learning versus deep learning. This is not a video customized for manufacturing. I believe it's actually for data science. I found this on YouTube, but I actually felt like it really applies quite well to our industry. So every time you hear the word data science, just swap that out and replace it with manufacturing, and it's actually a really good fit. So with that, please go ahead and start the video.
Hello and welcome to CAD Guild's tutorial on data science. In this video, we will explain the difference between three key concepts: artificial intelligence, machine learning, and deep learning, to understand how they relate to the field of data science. First up, artificial intelligence, or AI. What is it? Artificial intelligence is simply any code, technique, or algorithm that enables machines to mimic, develop, and demonstrate human cognition or behavior. We are in what many refer to as the era of weak AI. The technology is still in its infancy and is expected to make machines capable of doing anything and everything humans do in the era of strong AI. To transition from weak AI to strong AI, machines need to learn the ways of humans. The techniques and processes which help machines in this endeavor are broadly categorized under machine learning. Machines learn in predominantly two ways. Their learning is either supervised or unsupervised. In supervised learning, machines learn to predict outcomes with help from data scientists. In unsupervised learning, machines learn to predict outcomes on the go by recognizing patterns in input data. When machines can draw meaningful inferences from large volumes of data sets, they demonstrate the ability to learn deeply. Deep learning requires artificial neural networks, ANNs, which are like the biological neural networks in humans. These networks contain nodes in different layers that are connected and communicate with each other to make sense of voluminous input data. Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. The three technologies help scientists and analysts interpret tons of data and are hence crucial for the field of data science. To learn more about these technologies, subscribe to CAD Guild's blog and YouTube channel.
A CAD Guild. Average is dead.
Okay, so I thought that was a really just nice video, kind of overlaying what these terms mean. In conclusion, basically deep learning is a subset of machine learning, which is a subset of AI. So when we talk about AI, we're talking about a lot of different things, kind of all bundled into one. And again, AI stands for artificial intelligence. And so we'll kind of explore all these differently throughout the presentation. So let's kind of take a look at what AI and automation working together really means. These are real life applications that I've seen with my own eyes in the field. That I really like and think are very valuable for AI. So one is picking. Picking is exactly what it sounds like. Imagine a big bin, maybe even just a barrel of monkeys, right? And you've got to pull pieces and parts out of this bin. And that's actually really tricky to do. It's been known as the holy grail of automation for a long time. And so, having the ability to capture three-dimensional data and information, translate that to X, Y, Z, pitch, yaw, and roll information for a robot to actually grasp an object is pretty tricky, especially being able to do it over and over and over again in a really consistent, repeatable fashion. So random bin picking is kind of the first one that bubbles up to the top. The next one is sorting. Sorting, I think of this as kind of like if you've got a manufacturing line, you've got a conveyor belt going down the middle, and we want to sort our apples that we've harvested. We've got yellow apples, green apples, and red apples. We want to put the red apples in the red bin, the green apples in the green bin, the yellow apples in the yellow bin. That's basically what sorting is, just identifying and picking and placing objects and putting them where they need to go. Kitting is kind of the exact opposite. If I wanted to make a kit for a turkey sandwich, imagine I wanted to do, make myself some lunch, I would need to grab a few slices of bread from one box, a few pieces of turkey from another box, a few slices of tomato from the third box, and put them all together in a kit. And then my assembler would actually take that kit and put it all together and make my turkey sandwich. As it's done now, typically the kitting person would walk over to the area where all of the pieces and parts are, and they grab everything and build their own kit, which is a pretty rote task. If you can have a robot do this for you, it allows your assemblers to spend more time assembling really the high value stuff as opposed to doing the monotonous tasks. Packaging and palletizing is really interesting, especially in today's era where we've got tons and tons of people buying boxes off of the internet. If you can think of a large company like an Amazon, for example, when they've got to ship out a pallet with 50 different box sizes on it, it's not always easy to figure out how to stack these boxes in the right way to minimize the amount of air. Again, the less air we ship, the more money and more effective and efficient our shipping is going to be. So having AI basically play a virtual game of Tetris for us, an instantaneous Tetris, and tell us exactly how to stack these boxes can be a really cool way to save ourselves money on freight. Inspection is huge. I am a manufacturing guy at heart, so for me, quality is the number one essence and importance in a brand. You want your customers to know when they buy something from you, it's going to be strong, solid, it's going to work, it's going to look good, it's going to be clean. And so adding AI into your inspection can help you, notice defects or flaws or areas of concern for rework before your product gets to your customer, which adds to your brand and your value and increases your business footprint. Another big one is analytics. And this ties back to the gigantic buzzword that we've all heard a million times, which is big data. I know that when big data first showed up, everyone was harvesting all this data, and what do we do with it? Well, the good news is that data hasn't gone away. No one deleted it. We just didn't have the right way to slice and dice it yet. And now we're kind of letting our AI robots go sift through data and look for trends that we might not expect. I know personally when I'm on Microsoft Excel and I've got a big set of data, I can try to pull out data that I'm looking for, but for AI, it can actually search for trends that we might not innately see. And that can be a really cool way to, gain insights on your business as well. That being said, there's tons and tons and tons of different types of AI out there that's being used in manufacturing. So if you're an AI solution provider and your solution is not on this list, that's cool, that's okay. Actually, I'd love to hear from you. So if you want to shoot me a note on what you're doing, I'd like to learn more. If you're exploring an AI solution that you don't see on this list, that's also okay. Feel free to bounce it off of me. This area is growing so fast that we're going to see AI in all kinds of different applications moving forward. So let's pop over to the next slide. This again kind of goes in line with what I was just talking about. These are the revenues that we're expecting to see all the way up to 2025. These revenues are going to grow exponentially for a couple of reasons. First off, we've got a lot of companies out there that are already generating revenue and more revenue, and as those continue to grow and snowball, we're going to see exponential growth, mixed with the fact that we're seeing more and more companies entering AI. So I expect to see exponential growth in number of companies as well as exponential growth in revenue per company. When you combine those together, that's where you see this really steep accelerant, and it'd be pretty interesting to see what 2030 looks like, or 2050, because I don't think AI is going to slow down anytime soon. These are some data and some metrics that we've seen in numbers of businesses in AI. This is a bit of an outdated slide. As you can see, it kind of cuts off in 2016, but it does show that trend, and we didn't see this. We didn't see a railroad spike or anything. We saw the trend continue. Here in Silicon Valley, there's more and more programs that I see. I'm sure every university around the world is got more and more AI content. So we've got dozens of kids coming out of Stanford and Cal, and not even just kids, people coming out with PhDs, full-grown, business leaders exiting university ready for, value creation in the AI field. So again, that's going to create even more exponential growth. This goes back to the number of jobs that we expect to see in the AI industry, and that we have seen over time. So again, congrats to you guys for taking the time to tune in today to learn a little bit. I think AI is going to be more and more applicable to everybody. So little things like this, taking little AI classes online, figuring out how it's applicable to you, and maybe even leveraging that in your own career. If you see an opportunity for artificial intelligence within your business, and you can, bring that value to your own business, that's going to help, take your career to the next level. The next slide here are the market drivers that we see, at least from our frame of reference. The first is expensive labor. Labor is only going to continue to get more expensive. We see this everywhere. Like you look in China, initially manufacturing was all outsourced to China because of cheap, affordable labor. Well, once people get skilled and more valuable, they want raises and promotions, and the cost of that labor goes up. So it gets more and more expensive to manufacture. And that's not a bad thing. We want our people to be making lots of money. But maybe we don't want those expensive people doing very simple, boring things. And that's where the robots can slide in to really allow skilled people to do more. As the robots continue to get more affordable, it makes even more sense to put them in. Again, think of very simple, straightforward tasks, putting small boxes into big boxes, loading and unloading equipment, things that don't take a lot of brain power. Those are really good tasks for robots and for artificial intelligence. We see this market, by the end of next year, having, over 126,000 units in the field. I think we're on pace for that. Universal Robots is approaching 50,000 units deployed worldwide. We have about half the market share for collaborative robots. So if you take all of our competitors and combine them and add them with us, maybe we're at about 100,000 units today. So I think we actually probably will exceed that number, 126, by the end of next year. Forecasted growth. So again, we see this being a $2 billion industry. I just watched a presentation yesterday that said by 2025, there's a lot of people that estimate this to be an $8 to $12 billion industry. So, that's 4x the growth over the next 4 years, which is pretty consistent with what I've seen in my 4 years in the industry. So barring any sort of, big change of course of technology, AI and collaboration is going to continue to grow. We see a lot of investment in automation and AI into electronics and automotive. And automotive makes a ton of sense when you think about it, because they're big, cars are big, they're expensive. Everyone wants them to be built very repeatably, right? You want your Ford F-150 to be the same as your neighbor's Ford F-150. And, it's one of the most expensive investments people make. So there's a lot of capital in the industry, and a lot of tiered suppliers that go all the way up to making a car. Electronics, we're seeing a similar trend. While the price of a smartphone is a fraction of the price of a car, you buy more of them, right? Typically, a car will last 20 years versus a smartphone might only last 2 or 4. So we're seeing a lot of investment into the electronics industry as well. This is sort of a breakdown of the revenue that we see in the collaborative robot market. Again, when you start feathering artificial intelligence into this, it's going to grow with it. That's why we're talking about these robots so much, because they, it's kind of cart and horse. And these are the fields that we see then. Again, electronics and automotive are huge. Right now, we're seeing a bit of a bump in aerospace. People are flying on airplanes a little bit less due to the pandemic. The slide didn't take that into account, but we do expect to see aerospace continue to grow, again, for that same reason, right? It's a very large, expensive piece of machinery, a lot of tiered suppliers that feed into this product, and lots of cool innovation along the way, keep the market consuming new product. This is a really interesting kind of outside of the box slide I like. It talks about the number of robots per 10,000 people. So if you look at Europe, that's 92 robots per 10,000 people. As an engineer, I would kind of simply, reduce that to 1 out of 100. So that means if you walk into a manufacturing plant with 100 people in it, the odds are there's a robot in there. If you walk into a manufacturing plant with 1,000 people, there's probably 10 robots. That's pretty cool because I don't think the average person really knows there's that many robots out in the world. And you can see, Asia and Australia is down at the bottom currently at 57. I actually expect this to rise. All the news and information I hear is, the manufacturing community in China is investing in robotics extremely fast. Europe we see is a very mature automation market, and then the United States is somewhere in between. So, hopefully the goal of this presentation is to encourage even more people to look at automation and AI. I want to see the U.S. continue to drive that number up and stay really competitive and on the forefront of innovation. The next slide here, this is kind of an interesting slide. So last year, only about 1% of the product that we sold into the marketplace had AI attached to it. Here in 2020, I've seen that number click up already. And the reason for this slide is to talk about the potential. Again, I think we're going to see more and more people coupling AI to their robots. I almost think of it as like a brain, right? If you put a machine vision camera on there, you've got the eyes. If you put it onto a mobile robot, you've got the legs. You put a cool gripper on there, that's the hand. We make the arm. And then you've got AI, that's the brain. And that's kind of a very simple, easy way to think of this assembly of automation components. So again, the AI is you might not always see it, right? It's on the computer processor running in the background, but it can be a very interesting and compelling part of an automation system. So let's take a look at some real life applications that we see, at least through our company here. So this has a little bit of overlap from the first slide that we talked about, packaging and palletizing, picking and placing, assembly, quality. Machine tending is a very good application for us. Typically, when you think of a machine, like a CNC machine, for example, you want to keep that machine fed and turning parts all day, every day, right? That's spindle efficiency. And the number that we see in the industry is 27% increase in spindle efficiency when you automate. And that just is because, there's nothing wrong with a human operator, but a robot is going to know the millisecond that the process is done, right? It's not going to have to walk around and check on other things. It's never going to, you go on a restroom break. So when you automate a CNC machine, you're going to see your output go up. And this is actually a really good way for you to make more parts with the talent you already have. If you've got a really skilled machine operator, you can buy another CNC machine and automate them and allow the same operator to make twice as many parts, because he's probably doing or she's probably doing some quality inspection at the end, making sure things are running smooth, making sure that the tooling in the machine gets changed over. So again, automation is a good way to leverage the talent that you've already got in-house. A couple companies that I want to talk about here. One is Vicarious. This is a Bay Area, Silicon Valley company. I work pretty closely with them, and they're doing some really exciting stuff in the AI picking and sorting arena. Again, this means you've got a gripper or a suction cup, some sort of end effector that's grasping items, and the AI is helping the robot grasp those items more consistently, more repeatably, more quickly, and actually doing these processes on the manufacturing floor. You can see here they're working alongside people. The people look really happy. The robots are picking stuff up. So that's a company called Vicarious. You can go check out their website, or feel free to reach out to me for more information on what exactly they're doing. There's another company here who's a Universal Robots partner. These guys have been partnering with us for a few years. Really exciting team out of Boston. They've got some MIT grads that founded this company. They're also doing picking and sorting. It's a different approach, a different way of solving these problems. They've actually put together a really nice video that explain what it is that they do, and why they're unique and why they're different and why they're valuable. And so I'll actually play their video that I found on their website, because I think it describes the company probably a lot better than I could. So let's start that video now.
Some said it was impossible, this holy grail of material handling automation. A robot will never pick and handle millions of different items in a warehouse. It won't be fast enough. It'll be too complicated, unreliable. And no one could afford it if it worked. Introducing RightPick 2, the first autonomous piece-picking solution for modern intralogistics, with the range, rate, and reliability, the 3 R's of robotic piece-picking. Leveraging Right Hand's Gripper V5, an intelligent grasping system, now with 2 kilogram payload capacity. Featuring Universal Robots E-Series Cobots for simplicity and flexibility. Equipped with the Intel RealSense Depth Camera D415 for precise measurements and low cost. And a new generation core processor running RightPick AI, providing intelligence and machine learning with every system. RightPick 2 delivers more of what you need most. Reliable picking from the first item, even from small bins, to the very last. Gently handling items using a combination of suction and compliant fingers. RightPick captures barcodes and integrates with the widest range of new and existing material handling systems via RightPick MCP, an industry-first standard software API for robotic piece-picking systems. With RightPick, you can pick from a range of goods-to-person systems, induct to sortation systems, sort to a put wall, pick single-item orders directly to auto-bagger systems, place to mobile robots, automate kitting processes. RightPick 2 is a full-stack platform with a pipeline of new skills and capabilities rolling out continuously for even greater utility for the operations teams who rely on it every day. New features will enable RightPick to auto-swap or replace suction cups and provide a robot team leader console with data dashboards, putting operations teams in charge of the RightPick fleet to serve the needs of e-commerce, retail, pharmaceutical, grocery, health and beauty, apparel, and other industries. More performance, more applications, more visibility and control, more value for the same price. Available now. RightPick 2.
So again, this is a really exciting company called Right Hand Robotics out of Boston. I'm more than happy to make an introduction or connect you, or if you have any questions about this company, feel free to reach out to me directly or go to their website and find their contact info there. Again, really exciting, cool company. Another company that I know and I've worked with is called Micropsy. They are out of Berlin, Germany, and it says guidance here. You know, I have a difficult time always describing this because it's such a delicate, cool thing that they do. So imagine you're picking or placing something that's got some variation to it. Being able to get that final little piece of the pick or the place is actually really hard. Imagine putting like a plug into a wall. If you're off by just a millimeter or two, the plug's not going to go into the wall. it's not going to work. So being able to have a company like Micropsy that can actually help guide that robot the last, final piece of the way and actually create that sort of finishing touch to an automation project is pretty cool. It's a lot harder than it sounds, and what they've created over there is pretty exciting. What we're going to see here on the slide here is also what we call UR+. What UR+ means is that's the company that we've worked with, that we've connected our engineering team with their engineering team to make sure that it limits the amount of integration that you're going to need if you do buy this product. So what I like to call it out-of-the-box automation. So traditionally, integration takes a lot of time and effort, and it's difficult and it's challenging. So again, we kind of merge our components together for you to make it smoother and easier for you, the end user. Another UR+ partner that we work with, pretty well-known machine vision company called Cognex. Cognex makes machine vision cameras, and they went out and purchased a small AI company or medium-sized AI company out of, I think it was Sweden, and the company's called Vidi, and they've got a suite of different solutions here: localization, feature detection, anomaly detection and segmentation, classification. So these are a few different ways that this software can be used with machine vision. Again, you'll see them as a UR+ partner. That means that we've already got some of that integration work done between our robot and their camera. We really like to use UR+ as a great way to expand our solution set. There's so many cool different solution providers out there that we want to work with. So we as a company view ourselves as a platform. And so if these partner companies are open to it, we'll work with them to make their solutions even that much easier for our mutual customer base. So again, really cool UR+ partner here with some really cool AI solutions. Let's see. So this is a company also in Silicon Valley called Instrumental. They work also on the inspection end. They're tackling a really cool problem. It's called dark yield. What that means is, imagine you're making a product and there's a failure and you don't know about it until it hits your customer base. Well, you've actually had a gigantic yield loss that you just weren't aware of. That's the name, dark yield. And so this AI solution can actually look for and identify failures and issues with your product that you might not be expecting. Traditionally, if you put a machine vision camera on your line, you're going to say, hey, I know I've got a problem with that screw in the top right corner of my PCB. So let's look for that. Let's make sure there's a screw there every single time. That's a great way to do it. But what if you're just beginning production on this product? It's a new product being introduced to the marketplace, and you're not sure where you might have challenges on your manufacturing line. You haven't set up your whole yield meeting to identify problems. This can actually catch that very early. So this is a great development tool as well as rolling into manufacturing tool. Started by some people who used to work at Apple. So obviously that company knows how to manufacture, and the people that founded this company know how to manufacture very well too, with quality at the center of the heart of their business. The next product here is called Actinab. That stands for Active Navigator. That's actually an AI solution from a company called Energid, who's now a sister company to Universal Robots. This is for bin picking. So again, think of a big bin of parts. Maybe we're loading these parts into a CNC machine for a certain process. The robot can basically take this bin and load a CNC machine and then unload the CNC machine. And you start with a bin full of raw parts. And what you end up with is a nice pallet full of processed parts ready to be move on to the next phase of your manufacturing flow. Pretty cool solution from us. You can reach out to me directly if you want to learn more about this one too. This is another Silicon Valley company. This is a company called Samsara. They do a lot of different types of AI. They've done a really great job of fleet management, which is kind of cool. So, you know, you can imagine if you've got a lot of different trucks driving around, and you want to track all these trucks and what they're doing and how they're operating and how to make it more efficient and how to make sure your stuff's getting delivered. Samsara is a good company for you. Again, you can check them out, or you can reach out to me directly, and I'd be more than happy to make some introductions. So you've probably seen a common theme in this presentation. There's a lot of people in the AI space that are using universal robots. So I created this slide. Why are people using UR? One of the nice things about AI is it's pretty robot agnostic, meaning they can package this brain, if you will, onto any type of robot. So why are these people choosing our robot to do all this cool development in places like Boston and Germany and Silicon Valley and Michigan? So the first is we're very easily and flexible to work with. We've got Ethernet communications with a lot of different protocols. We've got a nice real-time data exchange of 500 hertz. That's one of the fastest in the industries, meaning you can just really exchange a lot of information very quickly, which is great for AI systems. We've got a great network of value-added distributors to make sure that you're supported locally at your factory. So whether you're near a big city or we're out away from a big city, we've got a partner near you. We work really hard to listen to the market. So if you have a universal robot or you're working with Actinab or any sort of AI that plugs into UR, let us know. We feed that back to our R&D team in Denmark. Almost half of our company is R&D, and we're just coming out with cool stuff all the time. So it's a mixture of bug fixes mixed with new products, new cool ways to use the robot. And so for people who are in the cutting edge industry, they like cutting edge new stuff all the time. We've got kind of a cool little graphic over here on the right. Our programming language is very similar to Python. It's based off of Python, and as you can see here, according to the geeks that made this cool graphic, Python is it's what the Jedi use. It's the lightsaber versus the more rudimentary programming languages. I came up programming in C, which looks like the most rudimentary according to these guys, so that's pretty close to the metal. Just kind of hacking of hardware. But so we've got a very elegant programming language. One other factor is what I call our cool factor. Our cool factor is our founder, Esben Ostergaard. He invented this product when he was in college. And, if you get a chance to talk to him, I highly recommend it. Ask him what he thinks the future of the world is going to look like. He's got a very optimistic view of how manufacturing and automation can make the world a better place, and it's really easy to buy into and adopt this. And I think a lot of our customers and a lot of our partners buy into this too, which is why we've got such a great partner network, great customer base. It really, I think, starts at the top. Pricing. What does this cost? So we're seeing a lot of people investing through capital equipment. That's sort of the traditional way, right? You apply to your company to make some capital money available, and you make an investment. And again, you look at this from the ROI perspective. We also are seeing leasing or even price per pick. So think of software as a service, right? You pay $5 a month. Well, this is a way that you could look at your robot and say, okay, well, I want to pay X amount of dollars per day or X amount of dollars per operation or per cycle. So you can work with a creative leasing company or even a solution provider to look at robots as a service. This is a way to move that investment from capital expenditure over to operational expenditure. So if you guys are tight on capital or you don't have any capital forecast for next year or allocated for next year, you can look at automation in your operational expenditures. And CFOs really like that because you can say, hey, I'm going to spend $1 to do this operation, but it's going to save me $2. And you show the CFO, that means every part we make, we're going to add another $1 to our company's bottom line. That's a pretty exciting way to justify automation, to show you're going to start generating positive cash flow for your business the moment you turn on the robot. So a lot of different ways to justify this. Again, this comes back to the conversation of ROI, return on investment. The RIA, robotics.org, has a nice calculator. We'll see that number 27% down here, our expected productivity gain. This is just the generic numbers that were plugged into the site. So, number of operators, price of manufacturing, number of shifts we're going to be running this equipment. And that's going to go through and do these generic calculations. And what we're going to see over here, a system cost, we'll call it $250K. That's more based off of a traditional industrial robot deployment. Typically, we see collaborative robot and AI solutions a little bit lower than that. This is a good just ballpark number. We've got some maintenance costs that go in here every year, preventative maintenance, things like that. Operating costs, this is, electricity and operators, things of that nature. And then we're going to see labor savings. Again, this is where we're leveraging our in-house labor and allowing our high-valued people to do more with their time as opposed to the simple rudimentary tasks. Productivity savings, we're going to get more parts out the door. All this calculates over here to cumulative cash flow. For this one, we've got a negative cumulative cash flow the first year. Well, hold on. What does that mean? That doesn't sound very good. So this is where we want to look at the return on investment timeline. When do we get back to zero? Typically, we see in this industry, if you're able to get back to zero with under 2 years, that's considered a good, smart investment. So again, we see by the end of year 2, we're actually in the black, positive $150,000. So this calculation shows that within 2 years, we're going to be generating money based off of our investment, which is actually a good investment. So don't be scared if you see a negative in the first year. Obviously, if you're able to get an ROI of under a year, it's even more exciting. But we've even seen for really stable, solid manufacturing companies that have a long producing product line of time over 2 years too. So it all kind of depends on what your company thinks is a good return on investment time frame. Here's just a graph of those numbers we saw before. Again, we expect to see before the second year, so this actually says 1 year, 4 months, we should be net positive and generating over the course of 15 years, $3 million of revenue. So if you think your company could use an extra $3 million, check out AI and automation. Here's a cool video that we've got just describing some feedback on return on investment from some of our customers. This is AI and non-AI customers alike.
When we first started looking into automation, I was surprised to find that we could afford a 6-axis robot and a collaborative one at that. I assumed those systems cost hundreds of thousands of dollars. The return on investment on our initial system was less than 2 months.
The return on investment is less than a year, probably about 7 months.
The ROI on the robot was probably about a 4-month return.
For the ROI on purchasing the robot is slightly less than a year, actually. So I'm very happy about that.
With the price you can buy the universal robot for, it's stuff that you're willing to invest knowing how quickly you can get the ROI back on it. To give an idea of ROI investment, you're looking at a savings of about 34 days it takes to get the robot paid for, to justify the means of buying that robot.
We estimate the ROI was about 6 months at its current configuration.
So in case of robots, we found that in just 14 months, the robot will pay for itself.
The ROI on the robot, I would say the robot itself, payback was less than 4 months.
These robots are probably 5 times as cheap, or 1/5 the cost of a traditional industrial robot.
We think that this system will pay back for itself in under 6 months, and that's just based by the cost savings and increased output that it provides.
So again, these are just some notes that we've heard from our customers. Again, we want to view this from the ROI perspective and help your company grow and succeed and make more money. So if it's something you're interested in or learning more about, and you want to know who to contact, you can reach out to me. That's my email address on the screen. It looks a little dark right there. But that it's the letter T, and then T is in Tango, D is in Delta, G is in Golf, at our website, universal-robots.com. You can also find me on LinkedIn. Again, my name is Tim Degrasse, and you can also reach out directly to the AI solution providers. I always recommend that you ask for a demo or ask for a proof of concept. We're all in this industry set up to show you how this equipment's going to work for you. I've had some customers imagine, we can show you how to move a Coke can, but you say, hold on, I work for Pepsi. Our can is a different color. So even if it looks from the video like it might work for you and you have hesitation, that's okay. We're more than happy to work things out. The solution providers and our partners are more than happy to work things out. We want to make nice, clean proof of concepts for you that you can share with your team and show and create confidence that this is actually going to work. It's not just a science project. So reach out to us. We're here to help. So again, this is my contact info. I'll kind of leave this on the page for a second so you can grab it, and then I'll hand it back over.
Well, thanks very much, Tim, for your presentation and for your advice. We have time for questions. Please stay tuned. The audience may type questions for the presenter in the Ask a Question box on the screen, and we'll get to as many as time allows. Questions that we do not get to today will be posted online at www.controleng.com with the archived version of this webcast. Remember to download a certificate of completion or a copy of the presentation by using the Event Resources tab on the left side of the screen. And now, questions and answers with Tim. So thanks very much, Tim. I know robots are repeatable, but what are they doing to make them more accurate? Are there any plans to make cobots that can lift more?
Yeah, so cobots with lifting more is an interesting topic because there's always a trade-off between speed and weight versus safety. So again, it's a trade-off. Moving around a soccer ball is one thing. Moving around an engine block is another. So for the collaborative mode right now, we see most people not wanting to move things in a collaborative mode above 50 pounds-ish. That's kind of what people can lift on the floor themselves. So, we'll always look at making sure we can satisfy our needs, our customers' needs. Right now, our UR16 goes up to about 35 pounds, 16 kilograms, which is pretty heavy weight, honestly. So, we'll keep looking at that as a factory, as a company. But yeah, right now our repeatability is about 50 microns. So we've got the precision side really, really tight. And yeah, expect our company to continue to investing in innovation.
Great, thank you. Keep the questions coming. I see them coming in. How do you expect the robots to be capable of inference-based decision-making anytime soon?
Yeah, so this is where the AI is going to kind of come in. So, right now it's got basic logic paths built in, right? If-else statements, decisions off of IO, things like that. So AI is going to only allow the robot to make more, finely tuned humanistic type decisions. One thing I think of is there's a question in quality, right? Do you pick up the part and put it in the scrap pile? Do you put it into the rework pile? Do you let it go on down the line? So that's going to allow the robot to kind of infer more as this AI plugs in and gets more sophisticated.
Great. Another AI question. Can the use of AI be shown in a quality assurance operation, such as assembly or other processing environments?
Yeah, so this is, think of the company that I referenced called Instrumental. I recommend you check out their website or find them on LinkedIn. They've got some really cool case studies on using their AI around quality control. Their kind of unique way of doing it is trying to spot anomalies that are unexpected. So basically putting a bunch of parts side by side and kind of playing the game. One of these things is not like the other. You think that'd be easy, but it's not. That's really new, cool, cutting edge stuff. And then also Cognex has got some cool AI with with VIDI behind it. So those are two cool companies you can go check out and learn a little bit more and look for case studies on their website for sure.
Great. Can cobots be redeployed to do other tasks?
Yeah, so this is something that AI can also help with. So the more flexible and easy to use equipment is, the more easy it is to redeploy. I think of almost like a drill press or a bandsaw. You might buy it for a certain task, but then are you gonna be able to use it for other things, other projects? So definitely, the easier we can make it, the easier it is to redeploy, and the more it makes sense to use for different tasks on your floor.
Good. Another AI question. When these systems do not respond as expected to unknown or unforeseen events or circumstances, how do programmers analyze the behaviors that lead up to the AI making a poor decision? So how can it be improved?
That's a really good and interesting question. I don't know the exact answer to that. As a computer programmer myself, I would say you'd probably just take the code and extrapolate it and kind of walk through the case logic and figure out where and why a robot made a decision, right, and to go left as opposed to go right. The good news is with collaborative robots, we've got protective stops built in. So that's a nice way to feel comfortable and confident that even if the robot does make a mistake, it's going to stop. So you're not going to break your product, you're not going to break your robot, you're not going to break your equipment. So, the cost of those mistakes are fairly low, right? You just walk over and turn it back on, or you can even build in a self-check to turn it back on. So, yeah, the debugging of a mistake, that's a good question. It's kind of probably depend on the coder and their way of debugging. Good question.
And some software would have some leeway built in, right? If there were some uncertainty, it would work the probabilities.
Yeah, good point.
Any usage of robots in agriculture?
Yeah. Oh, yeah. That's actually something I'm really passionate about myself. I live in Santa Cruz, which is, right next to, lots of agriculture. We've got Watsonville and Salinas. The entire Central Coast is all ag, and so we're always looking at that, right? How can you pick strawberries with robots? It's actually a lot harder than it sounds. So we look at, different types of automation. It's not always a robotic arm. So you might see, like automated tractors and things of that nature, automated berry pickers, automated fruit harvesters, nut shakers. There's all kinds of different automation in agriculture. And, We're seeing, again, the cost of labor rising in California, and that's driving more and more innovation into the agriculture space. So great question. Hit close to my heart on that one.
How or where do I reach out for programming training? I presume he's talking about robots.
Yeah, so one of the things I like the most about our company is we're very hungry to get more people trained. So we've got an online academy. You can just go to universal-robots.com/academy. Just type that in, boom, boom, boom. And that's going to give you a link to two different options. One is a virtual online academy. That takes a couple hours. It's the basics of programming our robot. I mean, I even asked my wife to do it. She's not even in automation, because I was like, check this thing out. You can put it on your resume. For 2 hours, you can get trained how to program a robot. So she walked through, she did it. That was pretty cool. We've also got in-person trainings that we'll host either at our distributor factories or that we'll host at our own plant down in Irvine. We've got one in Irvine. We've got one in Michigan, Dallas, Querétaro, Mexico, New York. Those are our American facilities. And then we've got live training all over the world. So universal-robots/academy, or you can reach out to us and we can loop you in.
Can two robots work in tandem? And I guess the add-on question would be, are they using AI to do that?
Yeah, good question. We actually have a project quoted right now with AI and two different robots. We're hoping to see that one move forward and get justified. And what that means is our robot is actually handing off a component to another robot. So you can see two robots working in series like that. You can also see two robots working in parallel. It's kind of a little bit less common to see two arms lifting the same thing at the same time. Mostly it's in series. So again, think of one robot picking up something and then handing it to another robot to do another task. And then that first robot going back and picking up something else. So if you kind of program that process flow, you can have a pretty smooth process cycle and not introduce any bottlenecks to your line.
Great. Time for one more question, perhaps. Can cobots be set up to do lights out manufacturing, perhaps to make a pile of things for first shift to address when they come in?
Yeah, no, great question. The kind of the dream scenario is you're a small shop and you got this massive order, and how do you figure out how to make it because you've got to sleep at night? Well, if you can set the robot up to do all this work at night while you're gone, your third shift, and you walk into a pallet full of, perfectly manufactured parts, that's the dream scenario. As far as lights out manufacturing, I mean, that was a huge talking point a few years ago that we heard, where you basically have this big sealed off factory and there's no one that ever goes inside, and you just push a button and then a bunch of widgets come out the other end. I'm not sure I really believe in that vision myself, because as human nature, we're programmed to optimize. I mean, if that was my plant, the moment that I push play, I'd send automation engineers to go back in and figure out how to make more parts faster. So I don't think that the vision and the goal for lights out manufacturing is as strong as it used to be. We're actually seeing, what we call in our internal circle, Industry 5.0, which is a harmony of automation and human operators. Again, I think everyone, even Elon Musk got quoted saying he might have overestimated what robots can do. Robots are very powerful, but human beings are phenomenal creatures, and our ability to make decisions and be dexterous with our hands and our fingers and use our eyes for really critical tasks is, it's so far advanced compared to what a robot can do. So I think that what we're seeing is a nice harmony between people and automation in what we call Industry 5.0.
Thanks, everybody, for the great questions. We'll get to as many of the unanswered questions offline as we can. And thanks again to our presenter, Tim Degrasse, for sharing his time and expertise with us today. I'd like to extend special thanks to our sponsor, Universal Robots, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on the screen as soon as the webcast ends. Please take a moment to complete it because this information will be used to improve future webcasts. On behalf of Control Engineering and Universal Robots, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.